Good morning, everyone. This is Robert Haynes with the National Weather Service in Burlington. We are at 9:55 right now on my clock here. We'll get started at 10 o'clock. Good morning and welcome to everyone. Welcome to those who are joining for this morning. We'll get started in just a couple minutes here. Thanks and welcome for joining. We'll get started shortly. All right. Good morning, everyone. We will now begin our warm season Skywarn Basics course for the season. Thanks for everyone joining in on this Wednesday morning. My name is Robert Haynes with the National Weather Service in Burlington, and I'll be guiding us through this presentation this morning. There is a questions tab on GoToWebinar. If at any point you have any questions, type out some of the questions in the box, and there'll be a few moments where we can go over some of the questions that you might have during the presentation. I'll have a few polls as well. Those should appear whenever we get to those points as well, and then I'll start them. They'll just have a few basic questions to help review and go over some of the information that we talk about today. And then lastly, there is a handouts tab where I have put in the base template for these presentations. So there is a PDF document there for you as well if you'd like to review some of this information later. We also will post any information on weather.gov/btv/Skywarn, where we upload the recordings for these so that you can look back at these later. So without any further ado, let's begin our warm season spotter class. So we're going to discuss this morning how Skywarn operates and why it's important to us here at the National Weather Service. We'll go over a review of storm ingredients, storm types, and our warning system here at the National Weather Service, and then talk about safety and how to report severe weather information to us. Our broad mission as an agency in the federal government is to provide weather, water, and climate data with forecasts and warnings that help protect life and property, that help you make decisions on outdoor recreation and anything of that nature, such that when bad weather hits our region, that you are prepared to respond adequately to any of the weather hazards that might face our region, and have a plan in place so that there's no need to panic for any bad weather that might hit the region, but that we can take measured responses to keep ourselves safe and make the most of the often beautiful weather, especially as we head into the summer months. We here at the National Weather Service in Burlington service almost all of Vermont. We technically do not cover Bennington and Windham counties in Vermont, but we have everyone else. And then we have the 4 northernmost counties of New York. So we cover St. Lawrence, Franklin, Clinton, and Essex counties on the New York side. We host a variety of different regions ranging from the broad open St. Lawrence Valley to the very hilly northern Adirondacks, the Champlain Valley, to additional hills and slopes within north central and south central Vermont, and then of course the Northeast Kingdom. So we have a lot of valleys sandwiched between high terrain, and even within those areas of high terrain, there are a lot of unique basins that add to a large number of microclimates within the region. So a lot to keep an eye on. Certainly makes the weather a lot more challenging to forecast than if our area was not flat, but at the same time, our region would not be what it is without all of those hills and valleys. Our duties, we do more than just provide weather forecasts and warnings. That's a pretty important piece of what we do, but we also forecast for general aviation. We do all kinds of things related to hydrology. One of these pictures of one of our old hydrologists taking snow core measurements are helpful for us to be able to predict spring flooding. We also provide fire weather forecasts for prescribed burns and things of that nature for recreational boaters. And we also maintain climate data and services. We'll occasionally, as time allows, depending on how busy our weather is, try and enhance our local knowledge of the weather that happens in our region. If there's any hazmat incidents, we'll provide support. We'll chat with state and local partners, especially with regards to public safety for large events. So if there are gatherings of at least 1,000 people or more, there is a good chance that there is a National Weather Service forecast being issued, or one of our forecasters keeping an eye on weather conditions in those instances for those large gatherings. And as we're able, we do outreach events where we may communicate with partners, like say our Local TV broadcasters will sometimes let them come in and see what we have available and give them a chance to see what it's like to be on the hot seat issuing warning products like our tornado warnings and severe storm warnings. We have a lot of fancy pieces of equipment, and we have a lot of degreed meteorologists on hand, but there's nothing that can beat ground truth. At the end of the day, we are stuck in an office setting. If time doesn't allow, we can't always step outside and see what weather conditions are happening across the region. And so Skywarn is a critical part of the National Weather Service in that it helps train people to recognize and report severe and hazardous weather information to us. So that helps us make life-saving decisions. That helps our situational awareness to be able to understand, like, okay, we've seen the storm move off the region from radar, but a phone call to say, hey, flooding is still taking place at this time helps us say, okay, we need to reissue those warnings to keep them going while flooding is still ongoing. So Skywarn has been around for about 70 years. It began about this time 70 years ago. So happy birthday to Skywarn and a big 70-year anniversary achievement for it. Skywarn is important because across the United States, we typically have some of the most severe weather across the globe. So a typical year will bring about 10,000 thunderstorms, somewhere about 5,000 floods, 1,200 tornadoes, 6 hurricanes, and really as far as deaths and injuries and the dollar losses, it accounts for about $15 billion in losses. So it's important for us to be prepared for severe weather. And it's really helpful to have spotters that are trained in recognizing hazardous weather conditions. About 98% of all presidentially declared disasters are weather related. So having spotters is really critical. I've mentioned we have a lot of fancy pieces of equipment. We have this golf ball like object is our radar. It's sending out a pulse to the atmosphere continuously to be able to observe any thunderstorms that develop, but even it has limitations. We'll go over one of those limitations here shortly. We have weather balloons that are sent up to collect weather data and information throughout the atmosphere to help forecasts. We have our weather models that help us. We have satellites and high resolution weather stations that take these weather reports by the minute, which are critical for aviation and other forecast details. They help weather models generate these fancy maps that we look at on a day-to-day basis. A lot of equipment that goes into making a weather forecast and observing the weather, but each weather instrument isn't perfect. They cannot adequately give us the full picture. And just to show this, the radar here at Colchester is blocked by both the Green Mountains and the Adirondack mountain ranges. And on the top left here, I have the lowest scan that the radar sees. And if this were the only resource that we were looking at, we would be almost clueless that there is widespread precipitation happening within the Northeast Kingdom of Vermont. You can see it as you go higher and higher up the radar scans that they see that precipitation. So that's one big limitation, is that our radar can't see beyond our mountain ranges. And additionally, our radar has to do this elevation scan just to account for the curvature of the Earth. Otherwise, if it were running at a flat surface, it would ultimately, the radar beam would run into the Earth if we just kind of scanned it at a flat elevation angle. So we have to do this to be able to see everything. But as a result of having the radar beam at an angle, we cannot see necessarily what's happening at the lowest 100 to 1,000 feet of the ground. And so radar may be seeing what is a broad area of rotation that is, say, 3,000 to 4,000 feet above the ground, but a spotter is going to be the person who might see the descending wall cloud that radar isn't going to capture. So based on a call to the Weather Service with a report, a location with the time of when you've observed those things, we can take that information and create warnings based on spotter reports. And so I'm not sure if you've ever seen in any of our warning products where we have listed that this warning is spotter reported, that these events are happening. So whenever a spotter reports it, we try and make sure that credit is given where credit is given, and also just to show the value that a spotter provides. Spotter began with amateur radio, but over its life cycle, it has expanded to first responders, such as law enforcement and firefighters and rescue workers, EMTs. But over time, it's also expanded into media and to research. We have a few students who are Skywarn Spotters, and ultimately, this really expands over to the general public. So in essence, anyone can be a spotter. The main requirement is that we ask someone to be trained by a National Weather Service forecaster, and ideally to build communities of Skywarn Spotters is really, really helpful to creating these networks. To highlight the benefit that spotters provided last year, I have a breakout of the local storm reports, which we issue for, say, snowfall measurements, for any damage related to thunderstorms, or if there are downed trees from particularly strong wind gusts. We will issue these reports. And last year, if we lump all of our citizen scientists and volunteers, such as co-op CocoRaws and spotters, that makes up 35% of the storm reports that we issued last year. So over a third of the weather reports and information come from citizen scientists like you. So we appreciate the reports that we get from our spotters, co-op and CocoRaws. And in particular, I'd like to give a shout out to the efforts that we've been making in the St. Lawrence Valley. You can see here that our efforts have been paying off. So huge thanks to all of our St. Lawrence Valley spotters out there. So at this time, I'm going to pause here. If you have any questions about the role of Skywarn and the role of the National Weather Service in providing weather warnings, now is a great time for questions. So we've talked about what Skywarn is with an overview of what the program looks like, how we use it, and why it's really important for us. We've talked about how we at the National Weather Service, what our goal is, and specifically who we here at the Burlington office focus on. And if there's any questions before we jump into our safety segment, now is a good time. I'll pause here to let those roll in. All right, not seeing anything at this time. Feel free to add those questions at any time during the presentation. But this kind of slide will be when we will be focusing on any of those questions that you asked. So let's take a quick talk about safety, especially as we are dealing with severe weather hazards and anything that has any concern for public safety. It's important to go over these things, even if they are sometimes a little cumbersome and boring. When it comes to severe weather hazards, it is important to start by being aware of the weather situation, regularly checking for forecast updates. Having multiple avenues of communication is also important. Cell phones may go out, or reaching out and having a dedicated network of friends and family that chat about weather hazards, or if you have other websites, or if you have amateur radio licenses or anything else to receive communications, having multiple avenues is really important. The escape route of this is that If you are caught in an active weather situation, you know where to go and how to get there to the assigned safety zones that you may have for severe weather. So usually that safety zone for most situations is going to be some type of indoor location. So if you receive weather warnings, have the knowledge and preparations to get yourself to that indoor location to keep you safe. There we go. As regards to most of our severe weather hazards, an indoor shelter is typically going to be the safest location. The only exception may be for flooding. If rising water is getting into your house, you may have to take more drastic measurements in those situations. And typically you want to find the interior part of the shelter. It is wise to stay away from windows, no matter the weather hazard. And of course our motto, when thunder roars, go indoors. And then as we head into the summer months as well, hydro is one of our biggest concerns. So dealing with flooding and things like that, we really like to stress and emphasize the turn around, don't drown part, because it's really easy to underestimate the power of water. About 2/3 of all flood related deaths are from people entering floodwaters. Whether that be by driving into it or walking alongside floodwaters and then getting swept into the fast flow of those waters. It only takes about 6 inches of fast flowing water to knock over and carry away an adult. And especially at this time of year when the water is cold, that cold water shock also plays a significant role in that. When we get to 12 inches, you can carry away cars. Larger SUVs and trucks can get away with 18 to 24 inches, but really it doesn't take much water on the roads to be able to carry away vehicles and people. And then the other thing with this is if you cannot see the road or the bottom, or even if you can see it, it's better to be safe than sorry. You don't know if a culvert has blown out below the roadways. You don't know if the water is going to cave underneath as you drive under it. Especially at night, avoid driving through flooded roadways. Best to avoid it. Turn around, don't drown. All right, and then as we head into the heat of the summer, it'll be important to remind ourselves about heat safety. Heat exhaustion and heat stroke are two dangerous heat illnesses that you can find yourself in. The heat exhaustion is kind of the first stage of it, and the heat stroke is the more serious stage of heat-related illness. It begins with feeling dizzy and thirsty, with heavy sweating, and then general weakness. As you move over to heat stroke, you'll stop sweating. Your body will not be able to cool itself, and so you will stop sweating at that point, and you may begin to faint at that point. And your sense of delirium begins to increase as you head to heat stroke. If you catch it at heat exhaustion, then you can cool off, seek shelter, find shade, drink plenty of water, take a pause to kind of collect yourself from the heat. But if you've advanced to heat stroke, call 911 at that point. That's a medical emergency by the point it has reached heat stroke. So know the signs of these heat-related illnesses, especially as regards to keeping safe in heat. Again, have those safety zones and escape routes just to be situationally aware of how to be safe in the heat of the summer. And then as a reminder to avoid leaving people or pets in enclosed cars as we get to the heat of summer. Have multiple ways to receive alerts. This is the best way to stay safe. Whether you have a NOAA weather radio, which is created to quickly reach these transmitters based on a variety of codes. If you need any help, there are web resources, and we also know the code numbers if you need them we can help you get those set up. Having alerts through your phones, the wireless emergency alert system, you can turn it on or off. We encourage you keeping it on so that you can receive heads up information through your phones. And then having a trusted TV broadcast or media outlet to help receive weather reports and information to your local area will help you stay safe. Having multiple avenues is important. There are a lot of text and email messaging services like VT Alerts is one example. Having weather apps can also help with alerts, and then also just having a good network of friends and neighbors can help out. Here I have listed all the known resources for our various warm season hazards in our agency. You won't be able to click the links, of course, here on this presentation, but I would encourage downloading the PDF, and that way you can access those links. The Storm Prediction Center are experts for severe storms. So as far as predicting severe weather hazards like hail, damaging wind, and tornadoes, these guys are the experts. We work in coordination with them when it comes to issuing our watches. Tornado watches and severe thunderstorm watches, that collaboration begins in the Storm Prediction Center. When it comes to flooding, the River Forecast Center watches our area waterways. The National Water Prediction Service has been expanding their capabilities of forecasting for creeks and streams that don't have river gauges. And the Weather Prediction Center are experts with flash flooding. The other resource that I want to highlight here is the National Weather Service Heat Risk, which uses an air quality like kind of style where it goes from this kind of yellow to red coloring that emphasizes heat risk to sensitive groups, and then goes upwards to, okay, there's heat risk for everyone. So if you or your friends are particularly vulnerable to heat, you can use heat risk as a resource because it has that kind of air quality style messaging for sensitive groups. The National Hurricane Center are experts when it comes to the tropics. The National Weather Service page has a broad overview of fire weather type stuff. The Storm Prediction Center has some resources, but really you can't beat local forest management services in terms of fire weather. And then for any of your local expertise, we here at the National Weather Service in Burlington are happy to help in anywhere in the region. Now, as we get into our how our headlines operate here, I'd like to emphasize the difference between watches and warnings. I like to use this baking analogy. So for any of those bakers out there, you know that there is importance in staging everything together to make sure that you have all of your measurements and ingredients in place. Weather works really similarly. We have to have all the ingredients set together to make severe weather. So a watch, like a severe thunderstorm watch or tornado watch, is saying, hey, things are staged to create severe weather, but the severe weather is not ready yet. The warning is when you get to the point where you've mixed your butter, cream, and vanilla, and everything is ready to make your cupcake. So your cupcake warning is it's been put together, it's been prepared in the oven, and you're ready to enjoy. The same thing with severe weather. All the ingredients are now come together, and we can visually see it on radar or satellite or our receiving reports. So the warning is it's imminent or occurring. When it comes to the heat watches and warnings, these work a little bit differently, so I want to highlight these as well. We try and give a 1 to 2 day heads up for these broader scale events like heat, and other ones include like wind chill, frost, etc. That take a day or two to kind of reschedule outdoor activities or consider changing plans or moving in plants indoors in the case of frost. These kind of things, these watches, we give a heads up like 1 to 2 days in advance to help you prepare for the event. The warning is these dangerous heat elements or say high winds are happening right now or about to take place. So when you receive events like the extreme heat watch or the extreme heat warning, know the difference that the watch is telling you to plan, that these things are possible. The warnings are that we have high confidence that high heat is going to put a strain and could lead to heat-related illnesses. So when you have the warning, try and avoid those heavy, prolonged, strenuous outdoor activities during the peak heat of the day. Flood watches are similar as we get into the peak of summer. Remember that flood watches indicate that flooding is possible. Same kind of idea with the ingredients. We're seeing things come together, whether that be unusually high stream flows, high amounts of rain, or things like that. It's important to stay tuned in those situations, but it's the warnings where the flooding is happening or is imminently about to occur. So it's at those times where you seek higher ground, avoid floodwaters, don't go near the common trouble spots that you see in your area that constantly have those kind of those threats on a day-to-day basis. So watches, conditions are favorable, the ingredients are there, but they're not all together yet. The warning is the time to take action. The ingredients have come together to produce these severe weather hazards. So during the watch phase, start looking at your forecasts, have your NOAA weather radio prepared, keep an eye on the sky, and use your trusted media outlets to take action when the warning hits. As another kind of overview, the watches are going to cover a much more expansive area because we're kind of focused on ingredients. Ingredients usually set up over a rather large area, but a small thunderstorm may only develop, say, in this part of the warning or the watch area where nothing happens, say, near house 2. So the ingredients were present over house 2, but they never came together to necessitate a warning like, say, what's happening at house 1. So watches are typically going to be broad. They're going to cover an expansive area. Warnings are going to be much more focused, highlighting on immediate needs and actions. You can find a lot of useful information in our graphical hazardous weather outlook. It outlines in green to purple, purple being bad, the weather hazards for that day, ranging from severe weather to lightning, excessive rain, hail, wind, fog, etc. So you can use this as a resource to help kind of gauge what weather hazards might be to each specific day. Because a lot of our weather hazards, we've been really, as an agency, working on trying to put this in multiple ways to help people understand it. Everyone's a different learner. Everyone sees things in a different way. And so we're trying to cover as many bases as possible by having scales that go up by color, by number, and by wording. And so here I have listed the Storm Prediction Center's risk categories for severe thunderstorms, from green to sure the thunderstorm is expected, but none of them should be severe, to marginal or slight, which would indicate that they're isolated to scattered, generally short-lived severe weather conditions possible, towards more of the oranges and the reds, like enhanced risks or moderate risks or high risks that indicate the potential for numerous or widespread severe thunderstorms that could be more persistent or long-lived. So whether you understand these by color, number, or wording, we've been trying to kind of spread these across the agency to make it as understandable to as many different peoples as possible. We have these weather maps. Each of these different categories are outlined on a map. So you can kind of get a sense for, say, hey, on this particular map, northern New York will be at a greater risk for severe weather as compared to Vermont on this day. And each severe weather hazard is subdivided into categories. So if you are particularly interested in what the tornado threat is, you can break those out on the Storm Prediction Center's page, and you can see whether there's wind or hail. And if there is the potential for, say, winds approaching hurricane force or hail in excess of 2 inches in diameter, the Storm Prediction Center will outline the regions where those type of significant or really big weather hazards could be focused. The Weather Prediction Center focuses on the same thing with excessive rainfall to try and outline whether flash flooding could be long-lived or isolated to localized towns or communities, or that same road that floods every time, or could the flood risks be moderate to high, where they cover a large region where flash flooding may occur, where flash flooding doesn't typically happen. So the moderate and high categories especially have significant risks to life and property in those situations. Most flood-related injuries or deaths will be associated with the Weather Prediction Center's forecasts for moderate and high events. Just like the Storm Prediction Center, they're mapped out as well. And so you can try and get a sense for your risk for flooding based off of this. That helps to kind of focus on the area of greatest concern. So really know how to find where you and your friends or where your specific towns are on a map, and that can really help in your interpretations of these. When it comes to issuing these products, we here at the National Weather Service may start on the outlook phase, where several days in advance we say, hey, the weather pattern, it's looking like it could be favorable in a few days for, say, strong or severe thunderstorms or particularly high heat or winds. We'll issue outlooks, as well as the Storm Prediction Center or several other agencies within the umbrella of NOAA will issue these outlooks as kind of a heads up. The watch phases will happen usually hours in advance, or in case of like heat, maybe a day or two. These are indicating that we're seeing ingredients come together. We have enough confidence that we really want to message the importance of being weather aware on that day or in that time frame. And the warning is, okay, we see things on radar, we're down to the minute to take action. And by having your escape routes and safety zones mapped out, you can take that action when you receive those warnings to save lives in the most critical of situations. And it looks like this slide got out of order, but this is something I'd like to mention as far as the tornado watch and severe thunderstorm watch. I think we sometimes have just some confusion on this, so I'd really like to highlight the main difference between tornado watches and thunderstorm watches is what the threat category for the tornado is. If it's moderate, it's always going to be a tornado watch, no matter what. If the threat is at least moderate, the Storm Prediction Center is going to opt for the tornado watch. But if the tornado threat is low, it will probably be a severe thunderstorm watch in those situations. And so I really want to emphasize that even though a tornado watch may be issued, the tornado threat may not be the highest severe weather threat in those situations. And so for this particular example that I have here, the wind threat, this was May 15th in 2020, the wind threat was considered the highest risk category on this day. So even though it may be a tornado watch, don't undersell the potential for dangerous winds or hail. Sometimes they can cause more damage than a tornado in our region. All right, so here we're going to have our first poll. What is the expert agency that initiates tornado or severe thunderstorm watch coordination across the country? So I'm going to open up this poll, and while this poll is going on, we are going to, I'll answer some of these questions here. So I've now launched that poll, so you should be able to see it on your screen here. So take a minute to look over that. Here I'm going to answer this one question. How does collaboration work between the various offices like the Storm Prediction Center, National Hurricane Center, Fire Weather, etc.? Is it only when those offices identify a threat, or do you check in regularly? How do you communicate? By email, phone, etc.? How do the probabilities work in the Storm Prediction Center risk categories? Is it within a given area or within a given time period? All right, so to outline how that works, we have kind of instant message type chats that we go over on a regular basis, where we kind of ping our neighboring offices like Albany, Buffalo, or Gray about various hazards. Or if we are dealing with larger national scale issues, like with the Storm Prediction Center and dealing with those kind of thunderstorm watches, or dealing with hurricane type situations, we usually have set coordination calls for those specific events. If we're doing like the regular check-in, we might just do an instant message. If we're identifying and working with a more significant threat, then we will be on coordination calls, chatting about weather ingredients and how they're coming together. And if things are slow to respond, or if we're missing someone, at that point, we'll just pick up the phone and go from there. So how do the probabilities work in the Storm Prediction Center risk categories? That's a great question, because they are different based on, say, the tornado threat. If the tornado threat is 5%, it's going to be slight, but you have to get up to a 30% for the wind before it transitions to a slight risk category. They have it listed on their page somewhere. I don't have it listed here in this presentation, but they have what each risk category is for each specific hazard, and what that translates to as far as like the marginal, slight, or high risk severe weather categories. The categories focus on a given area. They have a time frame that's a 24-hour window, but they're also working on experimentally putting these categories to time frames. And I think we've even posted a couple to social media at this point that emphasizes the time windows that these specific categories go, and not just the area. So that's an experimental thing that we are working on at this point. So at this point, we've got 91% of the votes in, and then we've reached about 3 minutes there. So I'm going to close this poll here. The correct answer for the agency responsible for initiating tornado and severe thunderstorm watch coordination across the country is the Storm Prediction Center. The fun fact with the National Weather Service at Norman, Oklahoma, is that it is it's right next door to the Storm Prediction Center. So in their case, sometimes their coordination will be someone from the National Weather Service office walking into the area where the Storm Prediction Center office is and just chatting. In-person stuff sometimes is the most effective thing, but though they are co-located together in the same building, it's not going to be the National Weather Service at Norman, Oklahoma. They will be focused on their local needs, but as far as a national view across the country, it's going to be the Storm Prediction Center. Each of the regional offices, like say Central Region or Southern Region or whatever, focusing on just a specific part of the United States as opposed to anywhere else. So, all right, so that covers the kind of basics on our outlooks and on our headlines. So let's go over what our warning criteria is. A severe thunderstorm warning is issued for thunderstorms that could produce wind gusts in excess of 58 miles per hour. Since we have so much terrain around here, typically we're going to be looking for downed trees or power lines in those situations. Sometimes you can get wind gusts as low as 50 that will topple trees and power lines. The other criteria is if hail is falling that's greater than 1 inch in diameter. Tornado warnings, whether that be by Doppler indicated rotation, or more likely in our region because of our beam blockage issues, likely by a spotter report of a funnel cloud. Flash flood warnings will emphasize fast flowing waters over roadways or rapid rises that threaten life or property in those situations. These are the convective style warnings that we'll focus on that will require immediate action, usually from anyone on the other end from there. Also, as a kind of heads up, our warnings follow this tier impact-based system where there's a base level where these are still significant weather events that can affect life and property, but we have tiers for especially dangerous storms. So sometimes in our warnings, you might see a considerable tag on those where they may indicate wind gusts near to above hurricane force, or you may see us apply destructive tags where they are definitely producing above hurricane force gusts, or they may be producing hail on the size comparison of baseballs. When we get to these destructive tags, the wireless emergency alert systems will go off because they are particularly dangerous and are a greater threat to life and property. This doesn't just go for severe thunderstorm warnings. These also count for tornado warnings. If we see a radar signatures that signify tornadoes that are more likely to produce the very high damaging wind gusts or about to reach high population density areas or where significant population gatherings are happening for some kind of event, or if flash floods are, say, starting to flood the entire first floors of homes, we might ramp up to considerable tags, or if widespread devastation to communities are expected, we'll elevate those to destructive tags. Or if snow squalls are expected to have significant impacts around commute times, we will consider those pieces of information to try and alert motorists or anyone who might be away from any kind of TV or phone system that these dangerous thunderstorms are arriving. So with that, let's look at some ingredients for how thunderstorms are developed. It takes a lot to pull together our ingredients. It takes about three of these things. You can sometimes have more or less of one thing. You can, like baking, have a little bit of a substitution here and there. But these are the three elements that you typically want to see to make thunderstorms. You want instability from the sun or by fronts that also provide lifting mechanisms. Our mountains also help. Any moisture source, say from lakes and oceans, are often the best resource for moisture. Any continental air that comes from the deserts or our mountains often do not have as much moisture and make it a little bit harder for thunderstorms to develop. So when you have these three things come together, that's when we have the greatest likelihood of thunderstorms. I'll use today as an example. There could be a pop-up thunderstorm or two across the area, but we don't have a whole lot of moisture around today. Our dew points are still pretty comfortable out there, and we don't really have any fronts in the region today. So we don't really have something to help thunderstorms rise into the atmosphere. But we have enough heating that there could be one or two. So from that instance, we have enough ingredients to make a few thunderstorms, but we don't have a lot of ingredients around today in the North Country to really make a lot of thunderstorms. When it comes to a typical thunderstorm's life cycle, typically what happens is heating helps a thunderstorm to begin developing. The atmosphere is colder as you go higher and higher. And so warm air will lift, kind of like in a convection oven. You have that turning of air upwards, and so a thunderstorm grows and develops high into the atmosphere. Once it reaches the stratosphere, or if it finds another stable layer in the atmosphere, it caps off there. The thunderstorm air cannot rise any further. And so at that point, rain begins to fall out of the thunderstorm and towards the ground. That rain causes evaporation and cooling in the atmosphere. And so this accelerates the downdraft to the surface and spreads out as it hits the ground. and over time it cuts off and ends the updraft that is in the thunderstorm. And so over time, your thunderstorm washes out. And so sometimes you might see kind of the base fall out from underneath it. So you'll just kind of see rain and residual high clouds that are kind of moving off as the thunderstorm has ended. Thunderstorm impacts will be greatest whenever the evaporative cooling process is strong enough to result in damaging winds. The most likely time that you are to see this occur is if you see a feature like an overshooting top. We often call the top of a thunderstorm the anvil top because it's kind of flat and almost shaped a little bit like the flat iron of an anvil. And so if you see little punches of cloud just above that flat anvil top, that signifies that the updraft in that thunderstorm is particularly strong, more likely to be severe in that situation. So you'll kind of see it way up high. Hopefully it's not obscured by the long distance from there. This overturning of air is critical to the formation of lightning. So I have this slow motion capture of a lightning strike in motion. As charge gets separated in a thunderstorm by the updraft and downdraft cycling, you have the separation of charge. A leader, which is what's happening right there, tries to make a connection with the opposite charge at the ground. And once that connection is made, I'll let this play one more time here. There's the leader making the connection. That discharge right there is when the connection between those two opposite charges are made. So lightning is that discharge as this flow of electricity is connected and made. It happens very, very quickly. That heat and that expansion of air from that electric discharge causes air to rapidly expand. And then once you have the lightning disappear, your air now rapidly cools. And so that is when the air comes back together and creates that clap, for which we sometimes call it a thunderclap. So if you've ever wondered that's how it gets that name, is air literally kind of is clapping for the discharge of electricity there. So just a quick information. So just an informative little thing there. So if you can hear thunder, you can hear thunder up to 10 miles away from the lightning strike. And lightning can actually strike beyond just 10 miles from a thunderstorm. So if you can hear thunder, you are within striking distance. So whenever you hear thunder, take action to seek shelter, go indoors, and stay safe in those situations. Now, that's a standard thunderstorm's life cycle and what lightning looks like in a standard thunderstorm. When you have wind shear, your thunderstorms can organize and will be much more likely to produce severe weather. So wind shear is that extra ingredient in your thunderstorm baking to produce severe weather. We've got two different types of wind shear. There's directional shear, which is ideal for supercells. This happens when the direction of the wind, say at ground level, is south or southeast, but at plane level, it's out of the west. That turning of the wind from southeast to west as you go higher up the atmosphere helps a thunderstorm rotate. That separates a thunderstorm from its downdraft. And so as a result, you have a longer lasting storm. The other type of wind shear is called speed shear or unidirectional shear. The wind is out of the same direction as you go higher in the atmosphere, but the wind speeds are a lot faster at plane level. And so you get these rolls to develop in the clouds that can enhance the evaporative cooling process in a thunderstorm and create stronger downbursts. And in longer lines, you can develop squalls in these situations. So this is what each of these look like on radar. In cases of directional shear, you will see features like the supercell and its classic hook echo. This is a product of the turning of the thunderstorm, where you have the rain shaft and the evaporated cooling air coming down on the back side of the cell. But on the north side, you have the air expanding out from this. We sometimes call this the V notch. That's good old fancy meteorology speak for you, where you see kind of this V shape where air is coming up into the thunderstorm, and then there's your downdraft. And that's what gives it that classic comma-shaped appearance that we have all come to know over the years. When you're dealing with a larger scale system like a derecho, I have the Adirondack derecho of 1995 here, where you have bookend vortices that help to reinforce strong winds to the south of wherever that bookend vortex develops. Speed shear is this is what the radar signature looks like for speed shear, where you have these long lines of thunderstorms. And on the back side of these thunderstorms, if you're ever looking at radar, this is what you'll see back behind it. You'll see, usually there's no returns behind it, but there is an area where there's still some level of return back behind the line of thunderstorms. This is where those convective rolls have developed in the thunderstorm. And so it'll be back behind this area where the strongest winds are expected, and especially where there's any kind of curve in the line, that will be areas where the strongest winds are most likely. And sometimes you can get a quick spin up or a tornado in those little notches in the line as well. And in a smaller scale, it looks a little bit more like this. It can be really subtle, where you have a thunderstorm that's developed and there's just a small area sometimes where you see lower reflectivities and small scale thunderstorms. But when you flip over to radar velocity, you can see enhanced wind speeds in those areas. And then when you have no shear, your radar is going to look a little bit more like this on the far right, where you have a blob that's just kind of sitting on the radar, or you just might have just scattered rain showers or thunderstorms that don't really have a particular level of organization or appearance to it. My general motto is that the more photogenic a thunderstorm is, the more likely it is to be a little dangerous. At ground level, this is what these will look like. Directional shear will look like wall clouds that are beginning to descend from the base of a thunderstorm. Usually these are going to be small and isolated. Your thunderstorm expanse may look like this, and the wall cloud covers a very small portion of it, whereas a shelf cloud is going to look a little bit differently. It's going to be these convective rolls that are developing, so you have rain behind it, creating this rolling air. And so out ahead of it, you have all this warm air lifting up, and at the interface of those, you have this long shelf that's been put together by the flow of air there. So it covers the entire horizon. So we sometimes have people confuse shelf clouds for wall clouds. And so the big thing is that a shelf cloud is going to encompass the whole area of a thunderstorm, whereas a wall cloud is going to be a small piece of it. And with little shear, you're just going to see mostly these kind of blobs of cumulus. You may see some stuff out ahead of it, but for the most part, you'll see a few larger storms off in the distance without really much organization. So the more photogenic it is, the more likely you need to keep an eye on it. I like to give a quick review here on how radar works and what it looks like. Radar offers a pulse that it sends out to the atmosphere. It's an electromagnetic pulse, and so anything that it comes into contact with, it bounces back, and so, or if some of it passes through. And so anything that it sees, it scatters that beam, and so some of that energy comes back to the radar. So naturally, the more stuff that comes back to the radar means that there is the more heavy rain in that vicinity. And so we can measure just the differences over time on how this water droplet moves, or how all of those different water droplets move. And we can get indications on how fast things are going for downburst winds or straight line winds. We can see hail, because hail scatters the radar beam much differently compared to water drops. And so it creates these three-body spikes, or hail spikes as we call them. And they also are very, very reflective. And so they often show up on radar very well. And so we can see those effectively. And then radar just gives us a good sense of storm structure and intensity. And so from that end, we can see the classic hook echoes to be able to produce severe weather. Radar scans at varying angles. So if you've ever looked at a TV broadcast of what those 3D views of a thunderstorm or hail core looks like, they're built by the fact that the radar is scanning at different elevation angles to see how tall a thunderstorm is and how, like, where those biggest, highest reflectivities are to find the large hailstones, or if a thunderstorm is even tall enough to produce thunder. We watch radar and we look at how the structure evolves over time. We look at the trends. Are the wind speeds coming up, or are the wind speeds coming down? Are things weakening or getting more organized? And we use that to observe the location and movement of these features that radar sends back to be able to predict severe weather. And so that's kind of the general gist, a really quick overview of how we use radar to detect severe weather signals. We won't go too much into each individual piece, but here's what a microburst looks like on radar. It features radar signature that has a velocity pattern where the inbounds in green, so this is wind or precipitation moving towards the radar, or maybe even bugs or birds that are fleeing the downburst are moving towards the radar. And at the opposite end of that same scan, you have winds moving away. And so from that, you have kind of the epicenter of your downburst. So as these winds come out of a thunderstorm, just kind of picture rain falling out of the sky, and when it hits the ground, it's got nowhere to go but out. So that wind can't go through the ground, and so it propels outwards. And so your epicenter might be here, and you'll see your trees knocked over radially outward from that. So it'll kind of flatten the surrounding area, kind of like a pancake. And so your trees will fan out from the thunderstorm. This is opposite to what a tornado kind of does. A tornado will instead feature damage that looks a little more like things are bent into wherever the tornado track does. So instead of converging, the microbursts diverge in terms of their path of damage. This is how it happens. Dry air entrains in a thunderstorm, and so that evaporation of rain, if the air is very moist, there's not a whole lot of cooling that can happen. But if the air is relatively dry or is moving into a thunderstorm, that accelerates winds as they move to the surface, and that creates the damaging winds that can take place in a thunderstorm. I have a nice video visualizing that. And so here out in the desert, you have plenty of dry air and greater visibility than forested Vermont and northern New York. So you can see how this downburst is kicking up dust as it moves out of the thunderstorm. The rain shaft develops over somewhere off in the distance, but you can see all the winds that are moving out ahead of it. And you can see how the turbulence from it is creating additional cloud layers where rain-cooled air is meeting this relatively warm air that has not been cooled at all. So I'll give one more view here of how that looks for the downburst. And so that's the downburst. This is a more organized look, the straight line winds. I have an example last year from a squall line that moved through late in the night last year, about June 14th, where we saw this line of thunderstorms with strong winds out behind it. This grouping of thunderstorms is usually pretty quick moving. And so you have your strong winds and then a little bit of rain back behind it. It usually produces a little bit more widespread damage. And it gets its fancy jargon term, the quasi-linear convective system, by the fact that on radar, it looks like a line. So that is the squall line, and these produce wind damage kind of usually in bits and pieces as the line moves through. And if it's more significant, it'll do things like this, where several trees in a long area extended along that line are knocked over. Derechos are a tier above even just the squall line in that they produce several hurricane force gusts over a 400-mile path that's at least 60 miles wide. So these are high-end events of straight line winds. This is the Adirondack derecho of 1995. So it'll be the 30th anniversary of that this year. And so as the line bows out, you can see the large area of reported damage. And I'm sure there was even more, as 2 million acres in the Adirondacks were affected. We have a climatology of about 1 in every 4 years. In 2022, there was one that went up through Canada that affected Ottawa, that did significant damage in 2022. But the St. Lawrence Valley was clipped by that in May. So we should be due for a bit. And as a heads up, this climatology map is only relevant to the United States. This has nothing to do with Canada, unfortunately. So, but we are not really due for one. So hopefully we'll avoid any of this type of event this year. I'd like to take a quick moment here to talk about hail formation and how that develops. We focused a little bit on wind, so let's talk about hail. Hail forms as water droplets move above the freezing layer in a thunderstorm. So in summer, these are usually like somewhere about 10,000 feet above the ground. So you can kind of imagine our mountains somewhere about there. So as a thunderstorm develops and moves above this area about 10,000 feet, you'll begin to form hail. And as it cycles in and out of the thunderstorm's downdraft, you get rings to develop. So if you ever have the opportunity, say for like a science experiment, like if you do anything with kids or something, try and preserve a hailstone if possible so you can cut it open and see the rings as new coats of water get put in as hail cycles below the freezing layer and collects water, but then gets moved back up in a thunderstorm to create new outer rings of hail. So the residency time is really important. If a thunderstorm only lasts 30 minutes, there's only so many times it's come in and out. But if a thunderstorm's updraft and downdraft are separated, such that the thunderstorm can last for 2 hours, you get more cycles that create that large hail over time. So really to create hail, you want to see a persistent thunderstorm. And so you want a supercell, usually for those situations. To record hail, measure from tip to tip, no matter how crazy the shape is. Measure it from one end to the other, and be sure to have your ruler. And if you think you may have a record hailstone, be sure to take a picture for proof. In fact, Vermont's record hailstone happened to fall in the backyard of one of our employees. So measure tip from tip and do it fast, because on most days where it's hailing, it's going to be 70 to 80, 90 degrees. So be sure to take it fast because it'll be melting. Hail appears very readily on radar. There's usually no doubt whenever a storm is capable of hail on radar by the 3-body scatter spike and by reflectivity values in excess of 60. So these are really just easy to spot on radar. Sometimes the question is how much melting happens before the hail reaches the ground. Supercells are ideal for pretty much all severe weather hazards. They are responsible for most severe reports across the country. They are named the supercell for this feature. I'm going to underline this because this is a key point to what makes them supercells. It is their strong mid-level rotation. Qualities of a supercell as a result are a long life cycle because the updraft and downdraft are separated as a result of wind shear. They are also capable of dropping very large hail as a result of this. I've got a picture of from Williston of a spotter that we have out there who captured this picture. Sometimes you'll see blues and greens in the cloud because hail scatters light differently from rainfall. And so when you're seeing this color in the cloud like this, that is a surefire sign that there is hail in that cloud. So these can last much longer than a standard thunderstorm, and about 1 in every 5 will produce a tornado. So it's not necessarily about the size or how much lightning is being produced in the supercell. It's all about the rotation. That is the key defining factor in deciding whether or not it's just a regular run-of-the-mill storm or a supercell. And of course, they have their classic appearance. We've seen this a number of times. And then another, just to re-emphasize, I can't say it enough, be sure to know how to distinguish a shelf cloud from a wall cloud. A shelf cloud will be unidirectional shear with these rolls over a big area of the horizon. Wall clouds are going to focus on a very small area of the thunderstorm and will be descending. That is another important piece of the puzzle. So be sure to know what a supercell looks like. There's a bunch of schematics out there everywhere. You'll often see the wall cloud where rain is falling on one end, but on the other end, it's precipitation free. And so you have the updraft occurring still in that point. And so that interface between the downdraft, the updraft, and the present shear are what helps give that part of that thunderstorm the rotation. So another review of what a shelf cloud looks like. I think we've gone over this enough. So let's go into our poll. We've gone over our warning system and how warnings are issued, how we use that, how we do that based off of radar. We've looked at all kinds of different radar signatures. We've gone over the different types of thunderstorms and how wind shear affects their radar signature and evolution. So at this time, we'll poll here what distinguishes a supercell from other storms. So I will open this poll, and we'll also use this as an opportunity to take a 10-minute break. So come back. Let's actually make it not quite 10 since we're running short on time. So let's come back at 11:15. So answer the poll and then ask any questions you may have. And then we'll come back here and answer those questions. So break till 11:15. All right, as we come back together from our break, I'll answer this one question here related to the differences between NOAA Weather Radio and the wireless emergency alerts. NOAA Weather Radio is tuned to, it'll go over every single warning that it goes over in that area. It also, we have like radio programs such as the area forecast for the zones, climate information, stuff about Mansfield snow depth, things of that nature will play on the radios. The wireless emergency alerts are going to focus on the highest impact events like destructive flash flooding or thunderstorms or tornadoes. The second question about months during the warm season for severe thunderstorms and tornadoes, we're about to hit the climate section there, so that will be answered soon. The other part of that question, the dry air that can help accelerate downburst winds, must not be too present at the surface. Is this dry air primarily in the mid-levels or upper levels? And the answer is yes. Usually it's at the mid-levels and the upper levels of the atmosphere because you want the surface moisture to help generate the thunderstorm. So you're exactly right, since thunderstorms require that moisture to form, that dry air is usually present in the mid-levels or the upper levels of the atmosphere. So you're exactly correct on that. For tornadoes associated with squall lines, is it harder to distinguish between a shell cloud and a wall cloud? I'd imagine both features would be present. Yeah, it's going to be tough, especially since in a lot of cases with squall lines, it's probably going to be a rain-wrapped tornado as well. And then when you add the difficulties with our terrain and with all of the forests that we have around here, I think it's very difficult to distinguish. So let's close our poll here. Everyone, it looks like a great number of people got the fact that supercells exhibiting mid-level rotation is the key factor to what distinguishes them. And to those who kind of mentioned like the separated updrafts and downdrafts, that's an important part as well, and that they form in moderate to high directional shear environments. Those are all correct. So those are kind of ingredients to create supercells in a way, but it's that mid-level rotation that is really that key distinguishing mark. And I guess it's in a little bit of a ways of feedback loop. You kind of need both of these things to kind of make it happen. So let's talk about tornadoes at this time. Tornadoes are violently rotating columns of air that are in contact with the ground. Let me actually put my slide back here up there. So tornadoes are violently rotating columns of air in contact with the ground. If it's not in contact with the ground, at that point it's a funnel cloud. These are relatively rare. 1 in every 2 years has one in the Burlington area. The challenge in our forecast area is that usually we have lots of hills or trees that make it kind of hard to distinguish whether or not you have a funnel cloud or a tornado. The one thing that you can do is look for things like lofted debris above the tree line. That can be a thing that gives you some level of confirmation that it's in contact with the ground at that point. There are a lot of tornado lookalikes out there. We get a lot of reports of scud. Usually they're convective debris clouds that are backed up against the mountain slopes. We'll get a lot of calls saying that they are tornadoes, but really ask yourself, is it attached to the cloud? Could you be mistaking it for a rain shaft, like in this photo where rain is fanning out from the downdraft and creating the appearance of something that really it's just the edge where optically it could look like it, but it's not. Ask if it's moving up into the cloud, because funnel clouds are always going to descend. And if asking to evaluate, it's really helpful to have videos in the time of occurrence so we can match to radar and really look for the rotation and any lofted debris. This is an example of a convective debris cloud that was called in, where you can see it's like this is kind of fragmented, doesn't really look like a wall cloud. Looks like it could be ascending up into the cloud layer as well. Didn't really have any distinguishing features that really qualified it. So We looked at this photo that was submitted, and it was convective debris. We didn't see any rotation on radar from at the time. Tornadoes are classified based off of the wind damage that they do. Of course, everyone knows of the Fujita scale. And so that is the work of engineers over many years and was recently upgraded, that focuses on the wind damage done to structures. And really even more research is now being done to try and figure out what it does to things like crop fields and things like that, because that can be hard to distinguish damage for those at this time. 80% of all tornadoes are going to be these weak EF0s and 1s, and they account for less than 5% of tornado deaths. They last short time frames. Most of our North Country tornadoes are going to be in this realm. Strong tornadoes account for about 1 every 5 tornado that develops. They are less than 30% of tornado deaths still, with lifetimes of about 20 minutes or longer and path lengths of about 15 miles due to more favorable conditions. It's the violent tornadoes that are usually more deadly. They're very rare. 1% of all tornadoes will be in this EF4 or EF5 category, but they account for 70% of tornado deaths. Unfortunately, because the conditions that usually create them are favorable, they last long and have long path lengths. Wind speeds in excess of hurricane force will strip a house off of its foundations readily. So unfortunately, there's not really much you can do to take shelter from these, which is why when it comes to tornado safety, in addition to interior rooms, it's also encouraged to wrap yourself up in blankets, or if you can drag your bed or some other type of covering with you, so that you can be protected from debris. And hopefully Vermont and northern New York will never have to deal with that violent level of tornado. Let's quickly go over flash flooding. Flash flooding, the key difference between a flash flood and a flood is that water is rising and flowing quickly. Floods arise from gradual contributions to river rises, or you have lots of standing water. I've got 2 videos here showing the ice jams at Ausable in January of 2018, and some flooding on the White River in Vermont in 2019, showing kind of the 2 distinctions where rain and snowmelt here did gradual rises, but ice jams caused blockages that caused this rapid rise on the Ausable that did considerable damage to local businesses in town. Flash flooding, here's the climatology of flash flooding. It's most common during the summer months when we have thunderstorms. You have other blips there in the early spring months and towards November from ice jams, but also from vegetation being in dormancy. And so it's collecting less water, and so more of that goes into runoff. We also have slight upticks towards the end of hurricane season as tropical storms like think Irene or Floyd interact with non-tropical systems to create these heavy rainfall events. But typically our flash flooding is going to be from training thunderstorms and localized environments in the middle of the summer season. So our flash flood climatology is ramping up, so we'll be keeping an eye on more lately. It's pretty much the same with severe weather. Severe weather is most likely during the summer months. Our peak month is the month of July. But as we are now entering into May, it's time to start thinking about more and more severe weather conditions becoming more common during the summer season. So the main reason is daytime heating is greatest in the summer months, and the Bermuda high that typically sets up in the summer usually puts a really strong moisture feed with the Gulf of Mexico. And unlike areas like Florida that don't really get fronts in summer, we still get weak frontal boundaries that cross the region from time to time. I'll note that the ratio of hail reports is actually going to be higher in months like May, even though you have more observations in July. You'll notice it doesn't outpace the growth of wind reports, simply because in this peak of summer, you'll get more melting of hail at that point in the year as compared to May, where things can still be at least a little bit cooler. The drop off for severe is pretty quick, but you'll notice that outside like the month of January, there's severe weather reports even in January and December. I mean, in February and December as well. So severe weather can happen almost at any point of the year, but really it'll be that June, July, and August time frame. Severe weather is most likely during the daylight hours because we need that afternoon heating to develop thunderstorms. So typically 1 to 10 p.m. For pretty much all severe weather hazards across the region. Some of it, though, boils a little bit down to the fact that some people may not be awake. There's usually a correlation just with population centers, more people being around to report those. It's a little less apparent in hail, but there is larger clusters still around most urban areas. Vermont and the Champlain Valley typically gets larger, hail is more common in Vermont than northern New York. Hard to say why, but you can see that northern New York has its fair share of large hail reports. And then tornadoes, there's a little bit less of a correlation with population centers. Typically, it's going to be in terrain features. So like the Champlain Valley and the St. Lawrence Valley, terrain is typically going to interrupt a tornado developing. That's not to say that more don't happen out in the Adirondacks. We just don't hear of a lot of the tornadoes that probably have occurred in the Adirondacks. So in particular, the Champlain Valley is going to be a little bit more prone in our region. The south orientation channels winds up the Champlain Valley in a way that is less common over the St. Lawrence Valley, which is going to favor a southwest wind as opposed to a pure south wind. And so that just gives a little bit more favorable turning of winds with height in the Champlain Valley. And so we've been seeing evidence of this recently, certainly in Addison County, but Franklin County and Chittenden County can also experience this kind of feature as well. And then even other hills and valleys, like some of the valley regions in the Northeast Kingdom can also sometimes get a tornado, as well as the lower Connecticut River Valley. All right, so here's our final poll for the day. The month with the most severe weather and flood observations in Vermont and northern New York is, poll. There we go, this one. And so take a minute to answer which is the most active severe weather month for the region. And while we do this, I'm going to answer here a couple questions. What is Vermont's strongest tornado on record? Vermont's strongest tornado is an EF2. That is the highest rating that we've experienced in our region. We have not had anything beyond that at this point. How does Lake Champlain influence the occurrence of or lack of severe convective weather? That is an important local effect that in the summer months, a lake breeze typically forms where on the New York side of the Champlain Valley, like say over Plattsburgh, you get a southeast wind. And so if you have anything coming from the west or a southwest wind that comes off the slopes of the Adirondacks that's kind of meeting that lake breeze, we often see thunderstorms initiate really quickly over the western side of Lake Champlain. And then as it hits the cold waters of Lake Champlain, we often see thunderstorms fizzle over the lake. But then as they get back over the eastern side of the Champlain Valley and start moving up the slopes of the Greens, we'll see them redevelop and blow up. So sometimes we'll see it skip towns in the Champlain Valley and then just blow up again as they make their way towards like Essex or Williston or towards Middlebury or east of St. Albans. We'll see some of that type of stuff happen. So Lake Champlain is kind of a sink where severe weather, it's a little bit less common. However, on the other hand, you have the less friction and less trees. And so with that more open area, sometimes winds will end up just accelerating out of the principle of not having that land friction or the lack of trees. So honestly, it can go either way, but that's kind of the gist of how Lake Champlain affects things. All right, I think we've got enough polling here, so we're going to close this. Our most common month is, everyone answered correctly, July. July is our most common severe weather month. All right, so as we wrap up towards the end of time here, let's talk quickly about reporting methods. We have our dedicated spotter line that our spotters can call in. It's a special number just entirely designated to spotters, so we know a spotter's calling when someone calls on that unlisted spotter line. We have on social media, if you report through there, kind of mention, hey, I'm a spotter in this area, or if you would desire, we have kind of basic codes for different regions that our spotters sign up in, and so you can always use that identifier to help us find that. By amateur radio, we usually listen more to this in the winter months to collect snowfall reports, but we are tuned into the whiteface repeater. If you have any storm reports, you can use our page there and fill out a form that reaches operations here. You can also report via MPing, which is an app, and you can always share your photos. Things to report include funnel clouds, wall clouds, tornadoes or water spouts, heavy rain, hail, damaging wind, flooding, or any weather-related injuries or deaths. First, call 911 on those, but then give us a heads up. That's something that we put in our storm reports as well, whether or not an event has caused injury or death. And your reports as spotters go a long way into helping us create these maps. These maps could not be created without all of the co-op, COCO-RAWs, and spotter reports that we receive, from ice to rain to sometimes winds to snowfall reports and the severe weather maps that we produce. Spotter reports go a long way into really filling out these maps, and these maps are important. They don't just go nowhere or are just to look good. They can be used in disaster declarations. They can be used to determine who is most impacted for insurance claims. These maps don't go nowhere. Excuse my double negative there. These can be useful pieces of information that are useful to helping our community. So don't underestimate the importance of what you can do as a weather spotter. So again, a huge shout out to everyone that makes these maps possible. A map demonstration of how MPing is used. You can use this to use your location services to fill out quick reports to send, and creates these animations that help us see things. If you're interested in more than just Skywarn, there's also the co-op and COCO-RAWs nets. I've got the contact information of co-op, which would be Marlon Farasami, and Seth Kudikoff, who handles our COCO-RAW stuff. The Skywarn Spotter Network is a volunteer network that's done as often as you want. There's like no obligation to the Skywarn Spotter Network. It's totally as much as you want to do. Whereas like the co-op and COCO-RAWs is a little bit more of a dedicated framework where you take daily observations where your sighting is important. But if this is something more where you're interested in something that's a little bit more dedicated, then those kind of programs are for you. The summary here for today, thanks for everyone for listening. I'd like to cover quickly what a reliable spotter does. A reliable spotter is critical to providing ground truth and potentially life-saving information, whether that be down trees or power lines or funnel clouds that help us get ahead of radar indications. Spotters are important. Storms come in all kinds of shapes and sizes. We've talked about how storms get organized, what they look like on radar, and how you can report that information. We've kind of given you ideas of when it's most common, resources that you can look at to anticipate severe weather, and we've gone over safety. We've covered a lot of ground in this hour and a half, and I don't expect us to know everything. There's a lot more we could go over. We spend semesters in college, so we spend 4 to 6 months on this type of stuff. And we do continual learning on a regular basis. So over my years here, we continue to review this stuff on and on. So I'm sure there's more questions out there. You're free to ask me or any of us any questions at any time. When you're doing any reports, be as specific as possible. You may not be familiar with all of your roads and cities, so reference nearby intersections, landmarks, or even a latitude, longitude point to help. And if it's something that you're interested in becoming a part of our spotter network, email or call our office and we'll get you set up. We usually ask people to provide a name, an address, or a lat long if you're not comfortable with your specific address being out there. or it's not out there. Sorry, we keep this in an encrypted sheet that goes nowhere but the two people, me and someone else who maintain it. And then a phone number if the need be that we make a cold call. It's very rare. We had one spotter who we called, and she said, I've been a part of the Skywarn Spotter Network, and this is the first time in 20 years that I've had a cold call. So it's very rare, but we sometimes make cold calls if we can't find reports out there. I've listed our report page, our spotter line that you can access, and then our social media feeds that you can reach out to as well. So thanks everyone for attending. Sorry for going a little bit, 5 minutes long there, and having to go a little bit quick at the end. Thanks so much for your kind attention. I'll stick around here for 1 or 2 more minutes just to see if any more questions come in. Thanks so much for taking a part out of your day to join us here today. I'd like to remind you, if you would like the handout, it's in that little tab there. You can download the PDF to get that as well. And we post the recording on YouTube of whichever session I think went best. So thanks everyone for attending. I hope you have an excellent day. I do have a question here about a special radio needed for NOAA weather radio. I have a very high frequency for kayaking already. Will that work? Yes, if you already have a very high frequency, you just can tune it to the frequency of that NOAA weather radio, and that would still work. The key thing with NOAA weather radio is to help people, because you don't have to have an amateur radio license for that. You only have the preset frequencies that go to just what those dedicated channels are. So there should be like no interference with those channels. You just select the frequency off of the NOAA weather radio and you go from there. But if you already have a VHF and you already have a license, then you can just tune over to that radio. They're usually about like 162 megahertz. They're somewhere in that range for frequencies. And I think they're listed on NOAA weather radio pages. So as long as you can tune to that frequency, you should be able to get NOAA weather radio without having to buy another one. But if you're not tech savvy, then you have that other option to buy a NOAA weather radio that already has them programmed. That it's more of like an ease of access kind of thing. All right, thanks everyone, and thanks for some great questions. Hope you have a great day, and we'll close things out here. Again, feel free to reach out anytime if you need anything. Bye-bye.